Hello friends, in this video I am going to explain you about the introduction to nonlinear data structure. Basically, the nonlinear data structure is there are two primary types, one is tree and another one is graph. A nonlinear data structure has no set of sequence of connecting all its elements or nodes and in each element can have multiple paths to connect the other elements. Such that such data supports multi-level storage as well and often cannot be traversed in a single run. Whereas in linear data structure, that elements have arranged that elements or data elements are arranged in a sequential manner, and each member element or each element is connected to its previous or next element. So in linear data structure, this connection helps to traverse in linear data structure in a single level or in a single run. Such data structures are easy to implement in computer memory, as we know it. In computer memory is also sequential. Therefore, the examples of linear data structure are, we are very aware about it, that array, linked list, stacks, queues, etc. But in nonlinear data structures that does not support the multi-level storage and often cannot be traversed in a single run. Such data structures are not easy to implement but are more efficient in utilizing the computer memory. Ultimately, it uses more amount of computer memory as compared to linear data structures. Some examples of nonlinear data structure that we have already mentioned: the trees and graph. All trees and graph, but not all graphs are trees. All trees are graphs, but not all graphs are trees, cause if there are certain edge which is connected or which is not connected, ultimately it becomes the tree. That is the reason all tree are graph, but not all graphs are trees. There are different types of graphs, different types of trees that we can definitely search it on, that definitely we can explain it. Then recursion is useful and it is the very easiest way to process them. It helps to keep track of what has been proceed and what remains. The graph is a nonlinear data structure. Graph can have multiple references in multiple references out, whereas tree nodes only has one reference in. Graphs can be directed or undirected, or it may be cyclic or acyclic as well. On the left hand side of the screen, it shows that various different types of directed and undirected graph as well. Trees is having a single parent, zero, or it may have zero or more children. A node with no children is called as leaf node, whereas the topmost node is called as the root node. N array trees, binary trees, these are the threaded binary trees, and so on. There are n number of different types of trees that we can also look into the matter when we are going to enter in that trees part in the next video. The n array trees, the best example of n array tree is your computer's directory system. It has a single starting point and then zero or more branches. A single normal computer directory is the example of an arrays tree. The next part of the tree is called it as the binary tree or binary search tree. Binary search tree allows for fast insertion and removal of elements. Again, trees, we can perform various operations like searching, like inserting, like deleting an element, inserting an element, or searching an element into the tree as well. They are specially designed for fast searching, whereas a binary tree which consists of nodes, each of which has two child nodes, maximum of two child nodes, each node consists of two child nodes. The such tree are called it as binary search tree. All nodes in a binary search tree fulfill the property that descendants to the left have smaller data values than the node data value. Node means root data value. On the left hand side of the root node, there always be the value which are less than the root node, and on the right hand side of the root node, there are the values which are present are always greater than the root node. Descendants on the right side of the root node have larger data values than the node data value. Node data value, we can consider it as the root node. BST tree nodes. This is important, and it is worthy of being repeated. All nodes in the binary search tree fulfill the property that descendants to the left have smaller data values and than the root node, and descendants to the right have the larger data values than the root node. Next, how to build a tree look like this. If the elements are given such that insert the following data into the binary search tree that has a root node of say 15 and the list of element is given to you like this. The element which is left than the root node will be kept as on the left hand side. The element which is on the greater than the root node shall be kept at the right hand side of the root node. So ultimately 15 on the left hand side of the 15 we should place 8, on the right hand side of the 15 we should place say 25, again 4 on the left, 8 of the left of 8, 10 on the right of 8, similarly 20 on the left of 25 but on the right of 15, and similarly 28 is on the right of 25 along with the right of 15 likewise. A binary search tree, it is where we can locate it is just the node which is on the left side, and on the right hand side again if there are n number of different nodes, we have to justify that whatever the element which is greater than the root node should be kept on the right hand side of the root node, and whatever the element which is having the size which is less than the root node shall be kept on the left hand side of the root node. The balanced binary search tree, that is balanced tree, each node has approximately as many descendants on the left as on the right as well. If binary search tree is balanced, then adding of an element requires the time complexity of order of log n time. Order of log n time is required. If a binary search tree is balanced, then adding of an element to add an element into the binary tree, it requires order of log n time. If the tree is unbalanced, insertion can be slow, perhaps as slow as insertion into the linked list. If the tree is unbalanced, so definitely we require the balanced tree as where it is possible. Then there are various tree traversal technique as we know. Tree traversal schemes include pre-order traversal, in-order traversal and post-order traversal. In pre-order traversal, it generates prefix order for the expression tree. In-order traversal, it generates the data in stored order, whereas in post-order traversal, it is useful for deleting the nodes from the tree. These are the depth first process. You will encounter the other process in the data structure as well. In nonlinear data structure, the data elements are hierarchically connected and are present at the various levels, whereas in nonlinear data structure, the elements are present at multiple levels, as we know, as we have just now seen the example of this of this tree. There are various different levels in which we can store the data elements. In nonlinear data structure are quite difficult to understand and quite difficult or complex to implement as compared to linear data structure, whereas nonlinear data structure are not easy to traverse and needs multiple runs to be traversed completely, whereas in linear data structure it can be traversed completely in a single run. In terms of memory utilization, the nonlinear data structure uses memory very efficiently, whereas in linear data structure they are not very memory friendly and are utilizing memory efficiently and are not utilizing memory efficiently. In terms of time and space, in terms of time complexity, The time complexity of linear data structure often increases with increases in the size of the elements, increases in the size of the list as well, or increases in the size of the data set, we can say. In terms of time complexity of non-linear data structure, or it often remain with the increase in size as well. So the recursive progressing example of these things is on the screen. We can void print tree node, current node. We can say if current node is not equal to null, then print the current data. Print tree which is on the left of this. If the size of the node is less than the root node, we can keep it on the left. If the size of the root node is greater than the root node or the node, then we can say we can shift it on the right side of the tree. A tree structure simply looks like this, whereas a graph structure is simply look like this. So this is all about the introduction to nonlinear data structure. In the next data structure, we'll see the various terminologies of tree, and we'll see the introduction of the tree in the next video. Thank you for patience hearing.